Good day and welcome to our project, the solar powered DC to DC e-learning kiosks here in Gilankwano village, Mina. This project is built to provide energy for charging of mobile phones, gadgets, and the rest. So this is the best version of the prototype we have come up with. This is the enclosure and system that houses the bulk of the systems that we use to charge the devices. Now we have a system that we charge phones just for now. But walking around through the system, this is the whole build we have now. Um, the main structure is composed of steel, which we welded throughout. This is to give us the main supporting structure. Then these are made up of aluminum composites. This is just to reduce costs for steel plates and help with heat management because having steel throughout or metal throughout this place would, in the enclosure inside, I will show you in a bit of a minute, would make the system a bit hot. So throughout this whole frames, this whole area is made up of aluminum composites. The same thing at the back too, made up of aluminum composite. And if we walk you through the device we have here, we are made up of those doors now, so we can access the devices we are plugging into the system. And walking into the device here, we it's mostly aluminum iron for the structure, and we have this acrylic glass to help with visibility, so we know who is coming in and who is going out. And for now, this is what we have come up with. These are USB ports. Each of it is made up of four ports that can supply about 2 amp using the USB 2.0 charging protocol. With the new project we'll be looking at pushing it up to 3.0 so that we can achieve more faster speeds and give our users even more benefit for the project. So at this point we have 1, 2, 3, 4, 5, 6, 7. So we have 7 of these ports that are here, and each of them can charge 4 phones at once. So we're looking at an average of about 28 charging capabilities for this system we have here. So this is the DC to DC converter. It takes the 30, 40 volts that the solar panel generates directly and converts it to 5 volts, which it is outputted here via these cables to these systems here. Each of them, yes, sharing the power across all of them. So this is how the system works. We take the voltage and the power from the solar panel. There are no inverters. They're not inverters. It's just direct DC to DC conversion. This helps us with efficiency. We can do things less complex. If you think of it, an inverter is going to be the most expensive of this build, but we are doing away with that. We are improving the efficiency here and we are reducing cost. So that was the reason why we opted for the DC to DC converter. I will go there in a minute and show you the solar panels. The system we have right now is composed of two 330-watt solar panels. They are about 30 volts on peak sun during peak sunlight, but when we actually measured it up to like 40 volts. So this is the nameplate of the device. Right here, the stated 330 from this manufacturer, Sun Solar, and these are the nameplate of the device what we have right now. So for maximum output is about 330 watts, and that was the reason why we chose this. So we connected both of them in parallel to the device, to the system there, so we can get power directly supplied to it. Now our system doesn't have a battery because the solar panel was here to offer power throughout the day. We were adding a battery so that we would not incur cost, but adding a battery for other backups, like during the day when with the solar panel is not that much, so that we can use that to offset maybe initial loading that people might want to come and charge their devices. So that's subsequent improvement we want to make up to the project. But as for now, this is the system we have now. So this device was made with the intention of having everything as low cost as possible, while we're not coming down on functionalities. So we opted for a solar panel for now with no batteries because we wanted to achieve just daytime charging systems. Subsequent designs would require that we add a battery to have it 24 hours operating. So whether any time of the day you can come and charge and give us a buffer so that maybe during the day when the sun is not up or maybe during rainy season we can have the power that we start and charge the battery with the other day, have this energy used up so that we can get consistent power delivery. So subsequent designs for the project will be including the battery, having a more refined DC to DC system, DC to DC converter system that support up to USB 3.0. And if we can push it, maybe USB PD that can give up to 100 watts of fast charging so that we can charge more like newer laptops and the rest of them. So that's overall, this is the design, this is the project, this is the design, this is what we have for now. We're looking forward to see we have a better version, and thank you for listening. God bless.